NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve a special system of equations using a simple algorithm. We set the chain of equal fractions equal to a single parameter t, solve each variable in terms of t, substitute into the linear equation, find t, and finally compute x, y, and z. Here is the system. The first line shows three expressions that are equal. The second line is a linear equation in x, y, and z. Step 1. Set the common value of the first line equal to a single parameter t. Then we will isolate x, y, and z in terms of t. First, declare the parameter t. Now solve each fraction for its variable. Step 2. Substitute these expressions into the linear equation. This produces one equation in the single unknown t. Step 3. Collect the t terms and the constants. Factor t and move constants to the other side. Now solve for t explicitly. Step 4. Back substitute the value of t into x, y, and z. We keep the answers clean in a compact form. If desired, you can write each variable entirely in terms of the coefficients. Here are the explicit expressions. Summary. The algorithm is straightforward. 1. Set the three expressions equal to t. 2. Express x, y, and z in terms of t. 3. Substitute into the linear equation to solve for t. 4. Back substitute to obtain x, y, and z. This method keeps the algebra organized and avoids messy simultaneous solving. Here is our problem. Three fractions are equal. Left parenthesis x minus 1 right parenthesis over 2 equals left parenthesis y minus 2 right parenthesis over 3 equals left parenthesis z minus 3 right parenthesis over 4. We also know that 4x plus 3y plus 2z equals -9. When several fractions are all equal, a powerful trick is to introduce a single parameter t. We'll first isolate the chain of equal ratios, then set them all equal to t. This immediately gives us x, y, and z in terms of t. Now solve each fraction for its variable. From left parenthesis x minus 1 right parenthesis over 2 equals t, we get x equals 2t plus 1. From left parenthesis y minus 2 right parenthesis over 3 equals t, we get y equals 3t plus 2. From left parenthesis z minus 3 right parenthesis over 4 equals t, we get z equals 4t plus 3. Great. Next, we substitute these expressions into the linear equation. The original linear equation is 4x plus 3y plus 2z equals -9. Plug in x equals 2t plus 1, y equals 3t plus 2, and z equals 4t plus 3. Now, expand each product. Combine like terms to isolate t. Move 16 to the right side and divide by 25. That gives t equals -1. Finally, substitute t equals -1 back into the expressions for x, y, and z. X equals 2 times -1 plus 1, which is -1. Y equals 3 times -1 plus 2, which is -1. Z equals 4 times -1 plus 3, which is -1. So x, y, and z all equal -1. As a quick check, substitute the triple -1 into the linear equation. 4 times -1 plus 3 times -1 plus 2 times -1 equals -9. Let's display the problem clearly. A powerful strategy is to name the common value of these equal ratios. We will call that common value t. Then each fraction equals t. Giving three simple equations, we can solve for x, y, and z in terms of t. Write each equality to t and solve. From x minus 1 over 3 equals t, we get x equals 3t plus 1. From y plus 2 over 2 equals t, we get y equals 2t minus 2. From z over 5 equals t, we get z equals 5t. Next, substitute these expressions into the linear equation. We plug x equals 3t plus 1, y equals 2t minus 2, and z equals 5t into x plus 4, y minus z equals 5. Carefully simplify to isolate t. We get t equals 2. Finally, back substitute t equals 2 to get x, y, and z. X equals 3 times 2 plus 1 equals 7. Y equals 2 times 2 minus 2 equals 2. Z equals 5 times 2 equals 10. Recap. We introduced a parameter t for the common ratio, solved each variable in terms of t, substituted into the linear equation to find t equals 2, and then computed x, y, z. This approach turns a tricky-looking system into straightforward algebra. In this example, we will solve for y from a 3-variable system using simple substitution. The system is x plus y plus z equals 38. Also, y over 2 equals z over 3, and x over 2 equals y over 3. Our goal is to find the value of y. First, convert the ratio equations into explicit formulas for x and z in terms of y. From x over 2 equals y over 3, we get x equals 2y over 3. From z over 3 equals y over 2, we get z equals 3y over 2. Next, substitute those expressions into the sum equation x plus y plus z equals 38. That gives 2y over 3 plus y plus 3, y over 2 equals 38. To combine the terms, use a common denominator of 6. 2y over 3 is 4y over 6, y is 6y over 6, and 3y over 2 is 9y over 6. Adding gives 19, y over 6 equals 38. Now solve for y. Multiply both sides by 6 to get 19, y equals 228. Then divide by 19 to obtain y equals 12. As a quick check, compute x and z using y equals 12. X equals 2/3 of 12, which is 8. Z equals 3/2 of 12, which is 18. The sum 8 plus 12 plus 18 equals 38, confirming our solution. Therefore, the required value is y equals 12. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.